All right, so in today's lecture, we're going to combine sort of what we learned in the previous two, and we're going to sort of use it to solve systems like this as quickly as possible. So what we're going to do at first is find the eigenvalues. So remember, we do this by taking the determinant of sort of the difference of our coefficient matrix. And the matrix that just multiplies everything by lambda. All right, so we have that. For this first part, we should get lambda squared, and then 8 plus 7, or 8 minus 7 is minus 1, I guess, lambda. And then we have minus 56. Here, this is going to be plus 3 times 18. 3 times 18 is 54. And I have lambda squared minus lambda minus 2. I set that now equal to 0. This one factors pretty easy. Plus 1 minus 2. And so my roots are -1 and 2. All right. Now, as always, time for some unnecessary explanation. So one way you can sort of choose to think about this is this means we could find numbers p, q, r, and s so that if I take the derivative of px plus qy, I get, say, -1 times what I started with. And if I take rx plus sy, I would get 2 times what I started with. And right, what this would tell us is, oh, if I take the derivative of this, I get negative what I started with. That means that this thing is some constant times e to the negative t. And similarly, since I take the derivative, get 2 times what I started with, that means, oops, that should not be pq, that should be rs. That would mean I get some constant times e to the 2t. All right, from there, I could go ahead and solve, and I would get, right, just looking at this, it should be clear there's no way I could get any other functions of t. I can solve for x and y right now. So I should get something like x of t is c1 e to the negative t times some vector ab, and the same for e to the 2t. Right, so really all this is saying is that, well, if I have a system like this, then x has to be something times e to the negative t plus something else times e to the 2t, and the same thing for y. So because we sort of know that without actually finding what px and qy are, though we could, so for instance, if I look at 2x prime plus y prime, looking back at my original equation, that would be 2 times -7x minus 3y and then plus 18x plus 8y. And that would leave me with, well, negative 14 plus 18 is 4, and negative 6 plus 8 is 2. So for instance, like I could go ahead and solve for stuff like that, but at the end, we're going to end up with something like this, and it ends up being faster to just go ahead and solve directly for this A, B, and C, D. All right, so we're just going to solve for those instead. And this is the step where we are finding our eigenvectors. So remember the way we do this. A lambda equals -1. And then I think the quickest way to do it is to take your original thing that we took our determinant of, and well, lambda equals -1, just make that lambda -1. So -7 minus -1. And we'll do one round of simplifying. So 7 plus 1, -7 plus 1 is -6. And we would end up with the following system. So let's say we go ahead and we solve for b in both cases. So -3b equals 6a. Dividing by -3b, we get b equals 2, or -2a. Same thing down here. b equals -2a. The fact that these match is a good thing. So in these problems, you can always just go ahead and solve the top one. But it's sort of a real easy way to just double check that you did all the steps up to this point correctly is to solve both and just make sure that you get the same answer. So with that, we can use this trick where our A coefficient is -2, our B coefficient is 1, and we just swap those. So A is 1, -2. And then, of course, the solution to this equation, I could always multiply by some multiple. So I can just add a constant C1 there. All right, we do the same thing for lambda 2. Oop, not -6, just 6. We go ahead and solve these. We should get something like -a equals 3b. And I'm sorry, I have those reversed. -3a equals b, and 3a equals -b. So again, we can see, okay, this is basically the same equation, doing the same thing as last time. We can just say, okay, our solution is going to be a is 1, b is -3. At this step, we're basically done. So remember, if we look at this, because it has to satisfy the previous equation, and when we take the derivative of this, we just end up with -1 times itself. that this needs to be basically our solution for AB. And so we can write down our answer now. E to the negative t times C1, 1, negative 2. Plus e to the 2t times C2, 1, negative 3. All right, I will do one more before ending on an exercise. So we're going to find the general solution to x prime equals the matrix 6, 18, 5, 15 times x of t. So we're just going to find the characteristic polynomial, 6 minus lambda, 18, 5, 15 minus lambda. And even though it's sort of technically wrong, I'm just going to skip the step where I even write it the other way, because I am much more used to writing it this way. Okay, 6 plus 15 gives me 21. And 6 times 15, well, 15 times 2 is 30, times 3 is 90. And then here, 5 times 18, I can pull out a 2, 10 times 9, and I also get 90. And so I get my characteristic polynomial, lambda squared minus 21 lambda, set that equal to 0, and I get lambda equals 0 or 21. All right. So I go ahead, if lambda equals 0, I just end up with the original matrix. And I should get, well, A equals negative 3b. And same for down here. So I can say that my eigenvalues are all of the form, or my eigenvectors rather, are all of the form C1, negative 3, 1. All right, doing the same thing down here. 6 minus 21 is going to give me negative 15. And 21 minus, or 15 minus 21 is going to give me negative 6. And I see that over here, if I divide this top one by 3, I get 5 and 6. And so I end up with the same thing. Again, just doing the swap method, coefficient of A is 5, so that's what B is, and coefficient of B is 6, so that's what A is. And that is my second eigenvector. All right, now I just write down the final answer. Note here that I have an eigenvalue of 0, which means that e to the 0t is part of my solution. That's just a 1 though, so I'm not even going to write that. I'm just going to write c1 negative 3, 1 plus e to the 21t c2 and then 6, 5. All right, just going to end it with an exercise. So I want you guys to find the general solution to x prime of t equals 0, 6, negative 1, negative 5. All right, so pause here, give that a shot. All right, so let's just sort of walk through. I'm not going to walk through, but I'll just sort of tell you what you should have gotten at each step. So for your characteristic polynomial, you should get lambda squared plus 5 lambda plus 6. Setting that equals 0, we have the roots negative 2 and negative 3. For lambda equals negative 2, you should have gotten c1, 3, negative 1. And for lambda equals negative 3, you should have gotten c2, 2 times negative 1. That gives us now our final answer. c1 e to the negative 2t times 3, negative 1 plus c2 e to the negative 3t times 2, negative 1. Right, and we will end it there.